Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the lectures on computer vision. The last lectures in transfer learning, we actually saw what transfer learning is and how we can import the pre-trained transfer learning models using Keras. We also imported the vgg16 model, and in this lecture today, our agenda will be to actually import the vgg16 model again and work on it and create a similar model as we created like in convolutional neural networks. We will be using the same data set, but this time we'll be using transfer learning models to train our data set, and let's see what is the accuracy that we get at the end of like a number of epochs. Like, is it better than like convolutional neural networks, or is transfer learning performing worse than CNN? So our main goal is to actually compare those, but in this we'll be preparing our model for like the data set that we already have, but this time using transfer learning. So without wasting much of our time on this, let's get started. So I will go up and fire my Google Colab, and in my Google Colab, as you can see, like I already have imported vgg16 model, but I told you like we do have two problems. The first problem is that the input shape is 224 comma 224 comma 3, and the output shape is 1000. So but we have used different parameters, right? So first we need to change the like input shape as well. So I will go over here, like you remember flow from directory where we actually use the input shape parameter. So go over here, and yes, we have this parameter known as target size, right? So I will just change it to 224 comma 224, and I will also remove the batch size from over here because I don't want batch size right now, because batch size is already taken care of by the my transfer learning model. So this is what we are looking upon. Like I have changed the shape from 220, like from 120 to 224, because this is what is required by our transfer learning model, which is vgg16. So I will go ahead and run this piece of code for you, and like this is now running perfectly fine. And now what I will be doing is I need to make certain changes now in the vgg16 as well, like where I was importing vgg16. So I need to pass in certain parameters. The very first parameter is obviously the input shape. So input shape is basically 224 cross 224 cross 3. I hope you are aware of that. Then, like how like a model does a prediction is, it does a prediction by using the weights, right? Because like the base of any of the neural network model is actually its weights. So we need to know the weights as well. So let's say the weight is weights, it's actually like taken from ImageNet, right? So it will actually download the pre-trained weight for you, and that is what is meant by a pre-trained model as well. The weights are basically saved. Like whenever we save a model, we actually basically save the weights. And then the last parameter we have is include top is equals to false. So this will tell me that I don't require the last layer of my like transfer learning model. Last layer as in the prediction layer where we actually make the predictions. So because the number of classes in vgg16 is 1000, but we do only have 10 classes while predicting our data set, like while predicting values for our data set. So that is why I have decided not to include the like the last layer, which is also known as the top layer. So include top is equals to false is the parameter that you are required to pass. So I hope you are comfortable with it, and let me just run this code for you now. And now if you see, this code has successfully ran for me, and like it's working fine. And let me just give you a model summary now. So as you can see, like our last block has basically now gone down the drain, and it has been removed because we have already given a parameter that include top is equals to false, right? And now what I'm required to do is I'm required to tell the model that okay, don't train the in between layers, like you have a input layer, then you have hidden layers, and then you have output layers. So basically what I'm doing is that I'm keeping the hidden layers absolutely the same, all the parameters absolutely the same. So I need to specify this to my model that okay, don't train the hidden layers, don't make any changes in their weights, and like they are not trainable, but I will be just using the last layer over here, and which will be my own layer, and I will be like combining it with your own model over here. So I need to specify this to my like model as well. So what I will be doing is, for I in vgg I dot trainable is equals to false. So this will be what this will be doing is that it will be telling that okay, this will be telling like okay, our model is like the inner layer of our models is not trainable, right? So I will run this piece of code for you. and it tells me it's not iteratable. Let me just check why is it giving me such an error. Okay, it should be for I in vgg dot layers, actually vgg dot layers. Yeah, so for I in vgg dot layers, vgg is the name of a vgg16 object. So while I am iterating through the vgg dot layers, I am just telling okay, I dot trainable is equals to false. That is, I don't need to train my like inner layers actually. So I will run this piece of code for you, and this has successfully ran. And now what I am required to do is that I'm required to basically flatten the output over here, because anyways it's a convolution layer. So in a convolution layer, if you always remember, we flatten the model, right? We did that in our previous convolution layer as well before calling out the dense function, right? Like we did this as well, like before calling out the dense function. So we have to do the same over here as well. Like this is what your convolution layer is at currently. Like our model is at currently convolution layer, and I need to flatten the output as well. So what I'll be doing is x is equals to flatten, and then vgg dot output, right? I mean flatten, whom to flatten, multiplied by vgg dot output. So I will run this piece of code for you again, and this should basically run. And okay, I guess I have not imported flatten over here. I need to import the required libraries, which have not been imported because of some issues, I don't know. Like let me just run it over here, and this should now work actually fine. Yeah, let me just check if it's working fine or not. And yeah, it's working fine now, because it was because flatten was actually not imported. So yeah, flatten is imported now as well. And now yeah, once this is done, like once my x is actually imported, what I am required to do is now I have to make in certain predictions, right? So in predictions, what I'll be doing is prediction is equals to dense. And here in dense, let's say I have 10 classes. Let's not say like I have 10 classes. And then the activation is basically, I hope you remember, it's basically softmax only. Softmax. And then I would have to multiply it by x, right? And I will run this piece of code for you. So this runs perfectly fine. And now I have to do one thing, like I have to now create my final model. So I'll be using from keras dot models import model, and this is one of the like required libraries that we're required to import. And then what I'll be doing is model is equals to model, the same that we actually imported just right now. And over here we have to give an input is equals to vgg dot input, and output is equals to predict, right? I will run this piece of code for you. It says it does not understand input, so maybe like let me check like what are the parameters that are required for input. So I will run this code, and it says me it takes in 3 arguments, inputs and outputs. So I have missed an s over here. Like these are some of the parameters that you should be aware of. I mean, if you are not, you could actually check over here, but you should actually remember this basically. So let me just close this over here and run this for you once again. And now it's like perfectly working fine for us. And now if I were to give you a model summary, so something like this, and yeah, so you see we are using 224 cross 224 cross 3 like input shape over here, right? And at last we also have the last 10 parameter, like the dense parameter over here, which is basically 10, and that was 1000 in like in the previous vgg case. So I hope basically now you understood how we actually did this, right? So it was not a very tough task. Like we just only had to do something like, let's say from keras.app, like we just imported the vgg16, and then once vgg16 was actually like then we actually told like okay, this is supposed to be my shape over here, and this is supposed to be like my weight, like image that is supposed to be my weight, and let us not just include top, because like the number of classes are not what I'm expecting. And then like I tell them that okay, these are the inner layers, and since these inner layers are not trainable, let us just like I don't want to train them, so let us just set them to false. And then we basically flatten our output as in we are used to doing 2D CNN model as well, and then like pass in the predictions value over here, and then made a final model out of it. So this is what our model finally looks like, and I hope you are comfortable with the idea of like using your like own models with x n number of classes in transfer learning. So I will meet you in the next one where we will train the model. So see you in the next one. Thank you.